Good day, everyone, and once again, your favorite uncle is back, and thank you for joining us. And we're still continuing, by the way, preparing for those final exams. If you haven't subscribed, please just tell your friends, subscribe. Just inform as many people as possible about the work that we're doing on this channel. It's our commitment to help you to not just make it through your final exam, but to actually thrive through your final exam. So we'll be giving motivation. We'll give you good content so that you are able to obviously do well for your final exams. All right, so now we'll be looking at the application of calculus. Okay, this is obviously on the 2021 May-June exam. All right, so let's get right into it. Right, so the first question says, okay, so we've got the graph f of x, which is ax squared plus bx squared plus cx plus d. That is two turning points. So they're telling us that the following information about f is also given, right? So now, what I'd like for us to do, so they give us f of 2 is equals to 0, and they tell us that the x-axis is a tangent. So we'll interpret all of that in this case so that we can be able to draw a graph. Okay, so the question is, without calculating the equation of f, use this information to draw a sketch graph of f, only indicating the x coordinates and the x intercepts and the turning points. Right, now let's get right into that. All right, now let's look at this graph. We know that we are looking at a cubic function, right? So in this case, we don't know whether the value of a is greater than 0 or it's less than 0. Remember, we said when the value of a is greater than 0, we know that we're looking at a cubic function that would essentially look something like that. It starts with a maximum and then it has a minimum. When a is less than 0, we have a function that looks something like that, where it starts as a decreasing function, and so it has a minimum and then a maximum, right? So we don't know all of that. However, in this case, let's start with the first thing that we know, right? So we know that they say f of 2 is equal to 0. What does that mean? It means that where x is equal to 2, okay, we are going to have and it's going to be our x-intercept, right? So we know we're going to have an x-intercept at x is equal to 2, right? So the graph is going to cut through the x-axis where x is equal to 2. Remember, this is where your f of x would be equal to 0, right? Right, so we know, let's put f of 2 somewhere there. So let's say that's 2 there. And then they say to us the x-axis is a tangent to the graph, okay? At x is equals to minus 1. Now, how can the x-axis become a tangent? So this is only when the x-axis are a turning point, or where, there's a turning point at the x-axis. So in this case, if a is greater than 0, what we're likely to see is a graph that does something like this at x is equal to 1, right? Okay, or if x is equal to or a is less than 0, so we're likely to see a graph that does this at x is equal to minus 1, right? So in this case, let's read on, because we still don't have sufficient information. But what we do know at the moment is that we've got a turning point at the x-axis. That's the only way that the x-axis can be a tangent, is if we've got a turning point there, right? Now, they say to us the gradient f dash of 1 is equal to 0, okay? So what do we know? Where is the gradient equal to 0? Again, at a turning point. So we know we're going to have another turning point where x is equal to 1, okay? So in this case, of course, if, it was a local maximum first, then we'd have a minimum there at 1, or if this was the case, obviously would have another turning point there. I'm sure you're beginning to see what this graph might potentially look like, right? Now, for us to know what happens, obviously the last information would be the one that becomes a determining factor as to whether we'll take, this graph above here, or we'll take the graph that kind of looks like that, the one beneath, right? Now they say to us the gradient at 1 over 2, a half, is greater than 0. So there's a half there, okay? So they say at the gradient, at 1 over 2, the gradient must be greater than 0, meaning that it must be a positive gradient, okay? So if you look at that, for this graph, you have a positive gradient there, whereas for this one, you have a negative gradient. In fact, it would really kind of help to change the color. So you have a positive gradient over there, and you've got a negative gradient there. So in this case, it means the winning graph has to be this one here, right? So I'm going to remove this one and just try to draw this one nicely, okay, so that we can see all the points that they are referring to. Okay, so in this case, it means our graph, first of all, we had at negative 1. So remember that we said at negative 1, our graph was a turning point there. Okay, so I'm going to try. Okay, so there's our positive gradient. We know at 1, we said f dash at 1 is equal to 0. So it means we've got another turning point at 1. And we know the graph cuts through the x-axis at 2. So this is what our graph would look like. Okay, I hope that you get the idea. Of course, in this case, with label our axes, we've got x there, and we've got y over there. All right, so I hope that makes sense, ladies and gents. Right, and we move on to now the application of calculus. Okay, I'll just try to expand this a little bit just to make it more visible. Okay, this guy is misbehaving. Okay, so they say to us O is the center of the semicircle through ABCD. Okay, the radius of the semicircle is x minus x squared units. For x is between 0 and 1. And they say triangle AOB is a right angle triangle. Okay, at O. Right, so in this case, they say show that the shaded part is given by that formula there. Right, now, I want you to just quickly think about it, ladies and gents. Okay, there I am just trying to make an annotation over there. So if you think about it, you've got that 90-degree triangle over there, right? That whole shaded area. I mean, not the triangle, but in this case, that part of your circle, around arc AB, right? So there's your arc AB, okay? And you've got that 90-degree angle there. Now remember, when can we have 90 degrees in a circle? Think about it. So if this is my circle, and I've got 90 degrees from the center, right? Do you agree with me that this would be a quarter of the circle, right? So it means that in this case, if it has to form a 90-degree arc from the center, in this case, therefore, it means that that would be a quarter of my circle, right? So in this case, it means that I am going to now say, well, it means if I'm going to get that shaded part, let me get the area of this quarter of a circle, right? So I'm going to say, look, so the area of, AOB, that arc there, so I'm going to get the area of a quarter circle, right? Remember, the area of a full circle is pi r squared, but this time it's going to be a quarter. So the area is going to be 1 over 4 pi r squared. Okay, right. So that's the area of that entire part there, that as I have shown you, right? But now, in order for us to get the shaded part, what must we do? We must now subtract from that the area of this triangle here. You agree with me? If we take that entire area and we subtract this area over here, then we are left with that smaller part that is shaded over there, right? So in this case, remember the area of a triangle is half base, so our base is going to be OB, right? But remember they said the radius is x minus x squared, right? But now we also know that should also be the radius over there. So this should also be the same, x minus x squared in this case. So that will be x minus x squared over there. Sorry for writing such in such an ugly way. By the way, when we take the area of a circle, we should have actually shown as well there that you've got x minus x squared, because it's pi r squared and our radius is x minus x squared. Okay. Our radius, by the way, is x minus x, but remember it's pi r squared, so we must square this entire thing. Okay, right, so that's the area of the arc there. So then we're going to I need to actually just label this, okay, number this. Okay, so now we take the area of the triangle. Okay, right, so in this case we're going to say, well, this is half of the base multiplied by the perpendicular height. And remember, our perpendicular height is going to be that OB there, okay, OA by the way, and our base is going to be OB. But so this is multiplied by perpendicular height, so this is half of the base is x minus x squared, right, multiplied by the perpendicular height, which is also x minus x squared. Okay, so in this case, what do we have? We've got 1 over 2 x minus x squared all squared, right? Now, remember, what were we looking for? We're looking for that shaded part. So we said we're going to take the area of a quarter of a circle minus that area of that triangle that we shaded there. It will give us the area of that small part there. So we're going to say, all right, so area of the shaded part is going to be the area of the quarter circle. All right, so that's going to be 1 over 4. Sorry about that. So that's 1 over 4 pi, okay, x minus x all squared, and that's all squared, pi r squared. This is the expression for r. Okay, so minus the area of our triangle, so that's half, that's x minus x squared, that's squared, right? So all that we're going to try and do now is, take out the common factor. Okay, so you can see how the common factor in this case is actually, when you look at it, you've in both instances you've got the square of that radius there, right? So what are we working ourselves towards? We're working towards having that on the inside there. So that looks like it's the square. So we've got 1 over 4 pi, right? So I'm taking out, in this case, that's minus 1 over 2, okay, into, okay, so it's that small section there, into x minus x squared all squared. Okay, so we're going to try and express that as a quadratic function. Now, in this case, we're going to just expand that bracket there. That's what I mean. Right, so in this case, let's try and work out the LCD here. So you've got pi over 4 in a sense, right? And you've got also 1 over 2. So our LCD is going to be 4, right? and you always say LCD divided by the denominator, right? So that's 4 divided by 4, which is 1, multiplied by pi, that will give us pi, okay? And again, you say LCD divided by 2, that will give us 2. 2 times 1 is 2, so that's going to be pi minus 2, okay? And then let's expand this part here. Remember, when you say x minus x squared, okay, all squared, what does that give us? So we'll have x squared, right? So I'm taking x minus multiplied by x, that will give us x squared. And then remember, what do? We multiply this one and we multiply by 2, right? So in this case, this will be minus 2x cubed, all right? You can take it step by step, okay? Plus x to the exponent of 4. So that's what it looks like when you expand it. And agree with me, ladies and gentlemen, it will look exactly like that. If you want to, you can actually write it as it actually appears there, over 4 rather. So that's over 4 into x exponent 4 minus 2x cubed plus x squared. Okay, right, and so we've proven that there. Right, now the next part of the question, they say to us, determine the value of x for which the shaded area will be a maximum. Now remember, in the application of calculus, anytime that we want to maximize something, we take the derivative, right? So we're going to say, right, so that's 10.2.2. We're going to take the derivative of the area. We are deriving the area with respect to x, right? Okay, so we're going to say area dx. Okay, so in this case, we are taking the derivative and making it equal to 0. Okay, so how will we get that derivative? So in this case, I'm just going to keep that coefficient there. Remember, that's just a number. It's as good as having 3 or 2 or whatever. So that's pi minus 2 over 4, right? Multiplied by, now let's take the derivative of what's inside. So that's going to be 4x cubed minus 6x squared plus 2x, and this is equal to 0. Remember, we are maximizing in this case, so we take the derivative and make it equal to 0. Okay, right, I want you to note, in this case, we can drop this guy down. We can divide by this on both sides, and 0 divided by that will still give you 0, right? Because it's still a number, so I can just keep those there. All right, so in fact, I can just be left with 4x cubed minus 6x squared plus 2x, which is equal to 0. Now, of course, we can try to solve this. Take out 2x as a common factor. Okay, all of them are divisible by 2x, so that will give me 2x squared. Okay, so we need to be careful there. Minus, in this case, we've got 3x, okay, and this is plus 1, and this is equal to 0. Okay, so we know when we take that one there, it means that 2x is equal to 0, so x is equal to 0. This will definitely not be applicable, because when we substitute it back into the original, that will simply give us 0, right? Remember, we are trying to maximize. Or in this case, we've got, let's factorize that guy. We will have, okay, so we'll have 2x and x, we'll have 1 and 1, we'll have negative and negative there, and this will give us 0. So it means that x will be equal to a half, or in this case, x is equal to 1. Now remember, we're trying to maximize, okay? So we already know that this one will not be applicable. Why? Because it gives us 0, okay? So let's test this one. So if we substitute a half into that equation, okay, so I'm going to have a half. Okay, let's try and get our calculator there. I'm going to have 1 over 2. Okay, let's take that there. So that's going to be 1 over 2. Okay, right. And we're going to say yx4. Okay, and we are therefore going to say minus. Okay, so let's delete that. So that's minus 2 into, again, it's 1 over 2. Okay, that's cubed. All right, so shift, that's cubed. And in this case, plus 1 over 2 again. That's squared. So I'm taking it back into the original equation. So I'm going to say 1 over 2. Okay, maybe I should have just put it in parenthesis. Okay, so in this case, right, so obviously I've got 0.0625. You can actually take it and so that's 1 over 16, right? So obviously I'm still going to take that 1 over 16 and multiply it by that factor. Okay, right, so that looks like that's usable. Okay, so let's check the other one. Now if we take x is equal to 1 and we substitute it back into the original equation, so that will be 1 to the power 4, or rather 1 exponent 4, that will give us 1. 1 cubed will still give us 1 times negative 2, that will be minus 2, all right, plus 1. I'm sure you can see that will give us 0. So it means even when we substitute 1, it will not be applicable in that case, right? All right, so I'm testing my solutions so that we know which one to go with at the end of the day. Right, so it means this also is not applicable. Okay, so it means the correct answer therefore is x is equal to 1 over 2. Okay, right, so I hope that application of calculus question, very interesting question. I hope that you are able to enjoy it. Okay, right, please don't forget to tell others to subscribe to your uncle's channel. All right, and I'll continue to give you good content and help you to prepare for your final exam, as obviously they are just upon us. Okay, keep working hard, ladies and gents, and I'll see you guys again next time. Sharp sharp.